Okay, this video is going to take us through an if-else structure that has more than two alternatives. So we covered one alternative with the if structure. We've covered if-else structure with just two alternatives. Now we're going to get into where we have more than two alternatives. And so we're going to take real-life type situations, and for this first example here that we're going to use to explain this process. And so we have here a Richter scale, which is real, and this Richter scale then is something that you could use to as far as doing an if-else structure. And so the chart goes like this. On the Richter scale, which is of course determines the damage that can be done by an earthquake based on its reading, Richter scale reading. And so from 8 on up, most structures are going to fall. From 7 on up, many buildings are destroyed. From 6 on up, you have many buildings considerably damaged. 4.5 and up, you have damage to poorly constructed buildings. And so the question is, how many alternatives are there? How many choices are there in this particular chart? The truth is, there's not just 1, 2, 3, and 4 choices, because what about less than 4.5? So you could actually go down 0 and up, and this could be something like there's no damage. So really, technically, if you looked at this, there's really 5 alternatives to this. So if you were to write an if-else structure relating to this chart, it could look something like this on page 5. If the Richter scale reading is greater than or equal to 8, then most structures fall. If else if the Richter scale is greater than or equal to 7, many buildings are destroyed. So you can use this chart to create an if-else structure based on the reading of Richter scale, the Richter scale reading. So what happens here? Now we have more than 2 alternatives. One alternative looked like this, where we had just an if structure, the if clause, just one choice. The condition, of course, relates to the Boolean expression. 2 alternatives, now just 2, now we start calling it an if-else structure. So if this one's false, it's going to execute this clause. So it's either going to do one or the other. Now, when we have more than 2 alternatives, now we introduce another type of statement. So here's an example with 4 alternatives. So you've got you introduce what's called the else-if statement. And so we have 4 possible choices. Either the compiler is going to execute this clause, or this clause, or this clause, or this clause. Not going to be 2 of them or 3 of them, just one of them. And so it says here on number 14, an if-else structure using more than 2 alternatives. The if statement is at the beginning. It's always at the beginning. And so you'll notice that here is that if statement. It's always the first line of a structure, a decision structure. So here it starts with an if, and then when there's 2 alternatives, start with an if, it always starts with an if. And then it says the else statement is always at the very end. The else statement is used when everything else above it, when there's no true conditions up here, then we are going to go ahead and execute the last clause, which is the else clause. So that's always the last one. And then as many else-if statements as needed. So as many else-if statements right here as needed and I can't remember what I was going to put there. So let's go with as many else if statements as needed between the if and else statements. So we have 4 alternatives. The first is if, the last is else, so therefore we need then 2 alternatives, 2 other alternatives, so 2 else ifs. Okay, so then we move on, and whoops, that's not what we wanted to do. And so now, let's go down here. So here's the point. The point is that only one clause will be executed. All right, so only one clause will be executed. So if there are 7 clauses, only one will be executed. 12 clauses, only one. That's it. Which clause will be executed? Well, it's the clause or branch associated with the true condition or the true Boolean expression. So the clause associated with the true condition or Boolean expression will be executed. If all conditions or all Boolean expressions are false, then the else clause will be executed. And so as we look at this, this is kind of how it goes. Let's say that this Boolean expression is false. Then what happens is, then this else or this if clause is ignored. Now, what I'm doing right now, what I'm modeling, is something that would be good for some of you to do when you are tracing code or tracing an if-else structure on paper, is to actually cross out ignored clauses. So let's say it goes to the next clause or the next statement, condition, and that condition, let's say, is also false. And then what's going to happen is, then it will ignore that clause. But maybe this condition on the third alternative is true. Therefore, the compiler will execute this clause, and then it will ignore the else clause. And so now to illustrate this line right here, if all conditions are false, the else clause will be executed. We could do, just kind of go through that really quickly, is that if this is false, this is ignored. If this one is false, then this is ignored. If this is false, then this is ignored. And so there is no test here. There's no test of any condition. There's no Boolean expression for the else statement. So this is just automatically executed. But all of these have to be false in order to get there. Because once it finds the true Boolean expression and executes that clause, it is done. The compiler is done going through that if-else structure. Okay, I think I'm going to talk about the story of the prince finding his true love in class. Because of time, I just want to kind of move on here. The compiler, here 17, evaluates each condition or Boolean expression in order. So it's got to go from top to bottom. It just doesn't go in a random order. It goes from top to bottom, so it goes in order until it finds the one or the Boolean expression whose value is true. And then it executes its respective clause, whatever clause is associated with that Boolean expression. So you can write that however you want. It executes its respective clause. And then all clauses before and after are ignored. All right, and so we've already demonstrated that up here when I crossed off ignored ones and then circle the one that was actually executed. Now, you're not finished with your program until you test each type of possibility. We have talked about this, but the key thing, this is really important, is to include the boundaries. And so I'm going to demonstrate this, and then we'll stop. And so this will be very important for you to see this. We're going to demonstrate this whole thing on a problem here. So let's say that we have a program that has a new testing or new grade scale, and so a person could enter their test score, and then they could find out what their letter grade is. And so the users ask for the test score. We establish a memory location for that test score, and we do one for the letter grade. So you have the letter grade, and I'm just going to go LG, and you have one for the test score, and and so let's say the user types in an 82, and so what happens is the compiler then evaluates this first Boolean expression. It's determined that 82 is not greater than or equal to 93, and so this is ignored. And then it goes on to the next condition, and the next condition, and because we're going in order from top to bottom, the next condition, 82 is not greater than or equal to 85, so this clause, the else if clause, is ignored. And then we go on to the next condition, and we find out here the test score is 82. Well, that's greater than or equal to 78, so this clause is executed. Well, it's not printing anything. All it's doing is storing a C inside this memory location. And then as we go on, this is ignored. This clause is ignored. And then I messed up here because I'm supposed to have this already down here. And then let's see, that's ignored, and then this was executed, so this is ignored and this is ignored. And then we're done with the if-else structure. This whole thing is done. Only there was 1, 2, 3, 4. There was 5 alternatives, 5 choices, and only one was executed, and it was the first. It's the clause associated with the first Boolean expression that's true. And because, see, if you were to put 82 here, 82 is greater than or equal to 70. Well, so that is true as well. But this is the first one. This is the second one. This one's ignored. And then at the end, it displays the results. It says your score of 82 is A, and then it goes to the letter grade up there, and it pulls out that C, and it displays the result of that. Now, what happens is if you were to write this program, it says you should test every possibility. So you have a 93 is your boundary. So you want to test a 94. You want to test the boundary is 93, and then you would test less than that, which in a sense you could go here to 86, and then you could test 85, and you could keep doing that until you test each different type of possibility to make sure this thing is working. But where a lot of students make the errors is whether or not they use that equal sign. Okay, so that's where you want to test your boundaries. All right, and so that should help you with tonight's assignment.